Alright guys, welcome back to another video here. This time we're gonna talk about debugging the game. So because the game runs in a Chrome web tab, you have access to a lot of the same tools that web developers use today to build websites and debug their JavaScript code. So one thing we're gonna do here is we're gonna hit Control-Shift-I. That's gonna open up our console window here, otherwise known as Chrome DevTools. Other browsers have similar dev tools inside of them. I know that Brave has it, Edge has it, Safari even has one too, though the layout might be different, but they all have generally the same features. Um, so one of the things starting out is we have our console window here. Now, as the game runs, there's various developer debug messages that can be printed out here. If you're going in and modifying some of the code, you can write a console.log, and then that could show up here as well. Um, One of the other cool features that exists in the Chrome DevTools is that we can actually look at the source code um, as it looked before it was compiled. So, as I said in the previous chapter, so because we used Webpack Dev when we compiled, we actually compiled from TypeScript down to JavaScript, and then it included a source map. So that source map has been presented to the browser, and it's able to take all the minified code and all the various things it does to make it web compatible and different things, and it reconstructs it back into what it looked like when we wrote it in TypeScript, along with all of our code comments and things like that. So it allows us to very easily look at the code files, make heads or tails of what's going on, and then we can do awesome things like we can come down here. Let's go into the update loop. So this ticks on every creature in the world, every frame. So we can actually come down here and we can put a breakpoint here, and the code will actually pause execution on this line right here. We have access to, we can see that it actually triggered on the module player, so that lets us know that the player is the object that we're currently previewing. There's only two creatures in this module right now, both the player and Karth. So if we resumed execution, we should see it should pause again, and it'll be a module creature now, which is the Karth object. We can confirm that by expanding this context, and we can scroll down, and we should be able to see, yeah, body model Karth. We could scroll down even further and probably find the tag, which would also say Karth. If I can find that here. Yeah, tag Karth. So now that we know we're actually looking at the um, Karth instance inside of this module creature. Uh, so we can also do some other interesting things too, because if you're in a larger module, you can have a bunch of creatures roaming around the world, and maybe you want to target a specific one. When you set your breakpoint, if you right-click on it, you can choose to edit the breakpoint. You can put some logic in here. So we can put something like this.tag equals Karth. So now if we set that, you can now see we have a question mark here because there's a conditional piece of logic there. So if we hit the continue again on resume script, the expectation would be that we would hit the player object this next time, but what you'll see is that we come right back around, and now we're paused again, and we're on the Karth creature again. So this is a way you can scope your breakpoints to the data that exists in the runtime. So there's a lot of things that can be done here. Of course, there are other variables that get modified later on in further lines, but those haven't executed yet in this iteration. But we can actually we can hover over this. We can see what its current value is in memory, since it's already run a few times. So we can also inspect it here in the inside of this window. But we can also come over to console. Because we're paused here, we actually have access to this variable because we're paused execution inside of that method on that class. So we actually do something like this dot tag, hit enter, and it prints out Karth. So there's a lot of things that can be done here. You can do this dot, and you can call some of the methods that are on the object itself, if that's what you're looking to do. You can inspect values, a lot of other things. So this is really something you can let your imagination kind of roam with as you're looking to work on the game itself. So another very cool thing that being done here to really hone in on performance things that you're trying to track down is to open up the Performance tab in Chrome DevTools and then click on the Record button. And what this is going to do once it initializes, it's going to record the timeline of all of the operations that are going on inside of the JavaScript VM. Once you have a decent enough snapshot, you can hit stop on that. It's going to build the timeline. A lot of times what I'll do is I'll hit pause here so that we can remove some of that GC pressure on the VM. I currently have screenshots turned on, but that's an optional thing. You can turn that off, but it can also help you make sense of where you're at in the timeline based on these screenshots. But if we open up a section here, we can see, we'll just take a slice of the timeline right here. And what we have here is everything, so this is every frame execution that we had, how many milliseconds that frame took to execute, and then the call tree that happened as part of that frame. So everything that happened from the beginning of the frame start to the render part of that frame is all encapsulated there. If we want to, we can squish this down a bit to get a better sense of what we're seeing here. So now we've got this animation frame. We can see that we call the game loop update. And of course, that goes through and loops through all of the various creatures in the game, the placeables, all that stuff, and runs their update loops. But as you can see here, this particular update loop took a decent amount of time. And if we dig further down here, we can see that module area update, module creature, update collision. So we can see that our collision logic is very, very, very taxing. Probably a lot of room for optimization there. So this at a glance, you can actually get a very interesting breakdown of what you're seeing on screen, but you can see it in this view here, so you can kind of break down what's going on. A recent feature that Chrome just added, which is very interesting. AI is all the rage these days, but you can actually take in, if you've got this feature turned on, a lot of it's controlled up here with the AI assistance panel. You can turn on different features. It's all turned off by default, but you can opt into different things. You can actually right click on one of these methods and you can actually ask it to, you can go debug with AI and you can identify time spent. Now, your mileage may vary as far as what you're going to get, but it's going to look at the code, it's going to look at what it's seeing in that graph, and it's going to try to make heads or tails of what it's seeing based on all the data that it has access to. So we'll run that. It's going to analyze the data. And now it's giving what it thinks the probable root cause of this, maybe how to tweak it, maybe how to make things better. So things like this can be, you can also continue just like any AI tool out there, you can continue to ask it more questions about what it found. You can go down different paths of questioning. Yeah, so this is a very, very helpful tool to debug performance issues and try to identify where the time is being spent in your frame loop.